All right, so for the last video, our journey has been trying to find the coefficients of the expansion for something like a plus b to the power n. We looked at some patterns. We saw that the powers of a decrease, powers of b increase, and then the coefficients are given by what we call the binomial formula. However, you've seen the binomial formula has some patterns, but it can be also cumbersome to calculate. Now there's an easier way to find these coefficients, and it's called Pascal's triangle. Here's how you construct the triangle. You start with 1 and 1, 1. Now you notice that there are 3 spaces here. You fill these spaces by adding the things above. Above this is just 1, so it's 1. Above this you have 1 and 1, so 1 plus 1 gives me 2. And you just have 1, so 1. Now when you do that, now you have 5 spaces. Again, you fill it up using the same logic. So this is 1. This is 1 plus 2, which is 3. Then you have this space, which is 2 plus 1, which is also 3. And you just have 1. Repeat. Now you have 1, 2, 3, 4, 5 spaces. 1, 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. And 1, 1. Keep going. Now you have 1, 2, 3, 4, 5, 6. That's 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And 1. Maybe one last. So you have 1. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 15. 6, 1. Now if you look at these numbers, let me use another color here, and you look at each row right here. So this is actually a plus b to the power 1 giving you a plus b, right? Because it's 1 and 1. This is a plus b squared giving you a squared, which is 1, and then 2ab, which is 2 plus b squared. This is a plus b cubed giving you a cubed plus 3a squared b plus 3ab squared plus b cubed. The coefficients are 1, 3, 3, 1. Now if you remember from the previous videos, the coefficient for power 4 were 1, 4, 6, 4, 1. And for 5 were 1, 5, 10, 10, 5, 1. So you don't have to calculate the binomial coefficient if you remember the Pascal's triangle. It's fairly easy to construct. One of your worksheet problem asks you to find patterns in the Pascal's triangle. Now there are some really obvious patterns, and you have to find new ones. I'm not going to tell you many. There's a symmetry like 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. They repeat, right? So they are symmetric about this line. Another pattern is more like a construction, 5 plus 10 is 15. Then there's one that I cover in the worksheet as an example, which is if you add these up, right? If you add them up, sum, this is 1. 1 plus 1 is 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. This is 16. This is 32. This is 64. So these are actually powers of 2. So it's really interesting that they add up to powers of 2. All right, that's the end of this video. This is an alternate way of finding the coefficients.